Some ligands have more than one atom with a lone electron pair. These are the chelating ligands, from the Greek word claw.
Our transition metal ion and the ligands around it create a coordination compound when they form with a counter ion, such as Cl- or any other compound. This will balance out the charge and make it a no net charge, which is favorable. One example of such a compound would be CO with NH3s around the outside and 2 Cl-. Go.
Coordination compounds were first discovered in the 1700s, but they were later fully understood in the 1890s.
The internet!
Now.
Well, if we consider what the primary and secondary valence refers to, the secondary is the ability for an ion to bond and come in close contact with ligands, as we discussed earlier. However, the primary valence is the ability for an ion to be attracted to another ion of the opposite charge, such as NaCl with Na plus and Cl minus. Now, back then they didn't understand what that meant. Today we know primary valence as oxidation states, and secondary, which is the ability to form with ligands, as coordination numbers. Coordination numbers are simply the number of bonds between the metal ion and its ligands. Let me ask you something. What's a coordination bond? Well, let me tell you.
It's formed by...
Oh, wait, Doc.
Put it on the right setting this time?
No, yeah, it's good.
Okay.
I'm recording at the moment.
In terms of coordination numbers, the number of bonds formed by metal ions to ligands in complex ions varies from 2 to 8, depending on the size, charge, and electron configuration of the transition metal ion. Many metal ions show more than one coordination number, and there is really no simple way to predict what the coordination number will be. In typical geometric figures, such as a linear structure, it is very simple to see that the coordination number is 2, with 2 bonds. In another figure, such as a tetrahedral, it is very easy to see that the coordination number is 4 due to the 4 bonds present.
What are you doing, man?
Oh. Thank you.
That man was confused. You're about to be more confused. But that thing always...
Now, class, we're going to discuss one of the most difficult things you learn in chemistry. Naming coordinate compounds. Now, I would know how hard it is. I've been a chemist, a doctor, a stockbroker on Wall Street. Do you understand what that means? I was making $800 a week. Now, and you know what? I gave it all up. Because I love teaching. I love education that much. Now, this is going to impact your life in a major way. So let me just collect myself. Look at the screen here. And we can see that when we're naming coordination compounds, always put the cation before the anion. Don't get caught on the regions. Now, hold on. Looking good today, Kelly. How's it going? Is that a new shirt? Oh, it comes to me after class. Alright. Anyway.
You can't put that in there.
Second rule. Always put the ligands before the metal ion or complex ion when naming the compound. Now, when naming the ligands, if it's an anion, you take the root of it and put O at the end, such as bromo or fluoro. And there are a few exceptions to the rule.
You forgot about the neutral part.
Oh yeah. Alright, so sorry our rules. Now, when naming ligands in the complex ion, if it's an anion, that means that you take the root of it and put O at the end, such as bromo, fluoro. However, if it's a neutral ligand, just name it. Andrew, are you with us? Hello? You're not going to go anywhere in life if you don't pay attention in chemistry. High school. Now, lost my chain of thought. Good one.
You didn't do the exceptions, Robertson's in that.
Yeah, I did!
You didn't say the exceptions.
What do you say exceptions for?
Alright, fine, whatever. All right.
Just leave it.